Explorers. My name is Courtney and I'm one of the educators here at Discovery Lab. Today I'm going to be guiding you through an experiment on water filtration. Before we get started with our experiment, let's go ahead and talk just a little bit about some background information and some terms that will be helpful to know while we are doing our experiment. So first of all, I said we were going to be making a water filtration experiment. So what is water filtration and why is it important? So as you probably know, humans need water to survive. And we don't just need water, we need water that is safe and clean to drink. The way that we make water safe and clean to drink is we use a water filtration device. The way the water filtration device works is that it clears contaminants out of the water that makes it safe and tasty for us to drink. So what is a contaminant? A contaminant can be anything that's physical, biological, chemical, or even radiological, a substance in our water. And typically, our drinking water may contain a small amount of different contaminants, an amount that's small enough and safe enough for us to drink. But if we have those contaminants in larger amounts in the water, they can become harmful to us. So how can we tell if our water has contaminants in it? There are actually a couple different ways that we're going to experiment with today. The first way is we're going to build a water filtration system. This will help us filter out some of the contaminants that we can see, like the physical ones, like maybe dirt or bugs. We don't want to drink those in our water. Other contaminants, such as chemical ones, we can't see with our eyeballs to filter them out. The way we can check for these contaminants is to use something called a pH strip. pH strips help us to tell whether or not our water is acidic, think like vinegar, or basic, think about soap. pH actually stands for potential of hydrogen, and it has a scale that ranges from 0 to 14. Acids range from 0 to 7 on the scale. They have the ability to donate a hydrogen ion. Bases range from 7 to 14 on the scale. They have the ability to accept a hydrogen ion. So for our experiment today, again, we're going to use both of those techniques I just talked about, the water filtration device and the pH scale, to test water and see if it's safe for us to drink. Before we start our experiments, let's take a peek inside of our bags and see what materials we have. Now remember, your materials may look just slightly different from mine, but they should all serve the same purpose. So we should have a clear cup, a booklet of pH strips, a cotton round or cotton of some kind, a mesh or tulle fabric square, a rubber band, a little beaker, a salt packet and a pepper packet, a fun tool called a pipette, a slide for a microscope, a magnifying glass, and a stir stick or stir spoon of some kind. Now, you should also have a source of water and your activity sheet. For our first experiment, you are going to want to collect the following materials from your bag. You will need one clear cup, a wooden stirring utensil, your pH papers, your salt and pepper packet. You will need a source of water, your activity sheet, and possibly a writing utensil so you can make notes on your activity sheet. Now, your activity sheet should contain a large pH indicator that you're going to use for the steps in this activity. So the first thing we want to do is fill our cup about halfway with water. And we are going to test the pH using one of our strips. So you will take one strip. We're going to dip it in the water for just a few seconds. And pull it out and wait for it to see if it changes color. While we're waiting on this one to change color, I'm just going to put it by the scale so I can compare it whenever it changes. Next, you're going to want to take your salt packet and you're going to pour it into the water. Now, what do you think is going to happen to the water when we add salt? Do you think the pH will change? Do you think it'll get acidic or basic? Or do you think nothing will happen? So we're going to stir the salt until it's mostly dissolved. Now we're going to check the pH again. So you're going to grab one more of your pH strips and do the same thing. We're going to dip it in the water, hold it for just a few seconds, and take it out. Then we're going to set it on the next pH scale again and wait and see if there are any changes as it dries. Now we're going to add our pepper. And we can think, what is going to happen when we add our pepper? Will it change anything? Will it change the color or the smell? So we are just going to stir that water up. Also, would you want to drink water that had salt and pepper in it? Some people may like it, but some people maybe don't. And again, we are going to test the pH by taking a strip, dipping it into the water for just a few seconds, and pulling it out and setting it down to compare. So now you should have 3 pH strips tested, 1 from the water by itself, 1 from the water with salt, and 1 from the water with pepper in it. Now we're going to wait just a few minutes to see if any color changes happened. If so, we're going to note them on our activity sheet where they are on the pH scale. Then I want you to think about looking at these pH strips. Which test has the lowest pH value? Which test is the closest to neutral, or that 7 right in the middle on the scale? Which kind of water would you like to drink? Would you like to drink the first water that you got from your water source, or the water with salt in it, or the water with salt and pepper in it? Finish your activity sheet for this experiment, and then we'll move on to the next activity. All right, for our second experiment, you're going to want to grab the following materials. You will need your contaminated water from our first experiment. You'll want to grab your pipette, your mesh fabric that looks like this, your beaker, your microscope slide, rubber band, cotton pad, and magnifying glass. You can also have a glass of water nearby, just in case. So the first thing we want to do is see what our contaminated water looks like. So you're going to take your slide, and we're going to use our pipette to put 1 or 2 drops of water onto the slide and see what it looks like with our magnifying glass. So to use the pipette, you're going to stick it in the water, squeeze the bulb at the top, and release it. Now you should have some of your contaminated water in your pipette. Then we want to take a few drops and put them on our slide. So your slide should have a few drops of water. And then you want to look at it through your magnifying glass. Now to use this magnifying glass, you want to observe it. I know sometimes it looks fun to do this, but if you do this, it looks all blurry. You can try it right now. It looks blurry and you can't actually see anything closer. So to use it properly, you want to hold it over your microscope slide and view it from a distance. You should see that when you hold it like this, it magnifies the image of the water that is contaminated. It makes it look bigger. So what you're going to do is look at it through there, and then on your activity sheet, you should draw what you see and what it looks like. So take a few seconds to draw that now. After you have finished drawing what your slide looks like, go ahead and dump that water back into your contaminated water, just to clear your slide off. And we are going to make our water filtration device. To make our water filtration device, you're going to take your beaker, your cotton you're going to stick on top, and then your mesh. You can fold it how you want. So you can either leave it big, or you can fold it 1 or 2 times on top of your beaker. Then take your rubber band and you're going to secure that around your beaker. So this is going to be our water filtration device. Now we're going to take our contaminated water and we're going to pour it on top of our water filtration device and see what we get. Now before you pour your contaminated water onto your filtration device, make sure that your cotton is around the whole edge of the beaker so the water doesn't just pour around it. Then very carefully, so you don't spill, you want to pour your water just enough to collect in the beaker to get a sample out. So I have poured not all of my contaminated water, but just enough to collect a sample to put on our microscopic slide. So you're going to take the rubber band and the cotton pad off, and then grab your microscope slide and your pipette, and you're going to put a few drops again onto your slide. So on your slide, you should have a circle of water, and then use your magnifying glass to look at it. Now, does this look the same as your first one? Does it look different? Take a few moments to record what you see now on your activity sheet. Now that you've had a chance to look at both drops of water underneath the magnifying glass, how do they look? Do they look the same? Do they look different? Would you feel comfortable or safe drinking either of those samples of water? Why or why not? Is there anything that you can think of that we could do to make that water safer or tastier to drink? Remember, eating or drinking a little bit of salt and pepper isn't going to hurt us. We have salt and pepper on our foods all the time. But does it water with salt and pepper and it taste great? Again, that's a preference up to you. So if you found our experiments fun and interesting today, then you could continue learning and studying to become a water engineer. A water engineer is someone who designs, creates, and tests out solutions to problems with water. Some water engineers do what we did today. They design materials and processes to clean water. Some water engineers help to actually dispose of contaminated water. And even others still help design solutions to problems caused from natural disasters that have to do with water, like flooding. So for your final activity today on your activity sheet, I want you to use your creativity, your imagination, and your knowledge from our experiment today to think like a water engineer. I want you to draw or design the steps that a water engineer could take to help clean or filter out water. Now, remember, most living things on Earth actually need water to survive, not just humans. So it's not only important for us to have clean water, but it's important for the animals and for the environment as well. I hope you had fun doing these experiments today, and until next time, keep on learning and discovering.